So I wanted to cover something real fast called the Lewis drift. It's an idea I just came up with because a lot of people are looking at this and going, "Oh, well, this is nonsense. You can't move out of your position in space, blah 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 blah." You know what I mean? Because you're kind of locked there, right? You're stuck here. So this is what I call the Lewis drift. And where is my paper? I wrote a paper on it, so you can see it here on my LinkedIn account. Boop, 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 and you can see it on my blog. So chain three orbs together and a gyro, and you get the Lewis drift. And this goes over the math of what you're going to see. So, and I know it doesn't really make a whole lot of sense when you think about it when you look at this, but when you see the actual model working. So this is the math. I have a post on LinkedIn that will like explain exactly what happens, blah blah blah. So we're all good there. So let's go back to here. No, sorry, let's go back to Algodoo. And we're going to see if I can make this thing work, right? So let's look at the momentums. Make sure everything's fitting on the screen. So you can see this thing's poised and ready to go. You know, it's just vibrating back and forth. It's just excited and ready to fly. Okay, so we're getting a little bit of shaking, but nothing's translating through here. Okay, so we're not moving, right? We're at 1. Let's pause everything. Let's go into axle. So it goes at 450 RPM. We're going to just toggle that off. 450 RPM, 5,000 Newton, blah, 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 per meter, whatever you call it. Boom, boom. Okay. These things, let's see, material, they weigh just standard. It's default material. Doesn't really say plastic. Who cares? This thing, same thing. Material, same exact. So 3 of the same size orbs. 1 axle or gear made out of the same material, so everything's the same. We have chains connecting these 3 together, and we have this thing here, which is just a loose chain. Okay, and so we're going to discuss something called the Lewis drift. I'm just going to show you what it is. I'm not going to tell you what it does or whatever, so I'm just going to boop, turn that on. Okay, we're just going to let it go for a little bit and see what happens. All right, so I just hit it real fast. Okay, so let's just look and see what is happening. Okay, I'm gonna hit 3 so I can stop it. Okay. I don't know if it's gonna do it this time or not. I think we might have it. Let's go faster. Go faster. Ooh. Okay. Let's see. I'm skeptical. I mean, you can really get it moving. I just wanted to kind of do it one shot and see if it does it, but just so you can see the mechanics of it all. Of course, every time I try to show you guys anything, nothing ever works. But you can see we're still moving, right? Just rotating. Let me give it another shot. That was 3. Turn it off. Boom. 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 And stop it. Okay. And we're going slow. Now again, it's a drift. So this is not the Lewis shooting out of your center of mass and rocketing into space. This is just drifting. Okay, but as you can see, slowly see. Right, and the problem with this is just everything's too heavy. All right, so let me just drop it down a little bit. Material, we're going to drop everything down to just like here. Okay, we're going to play it. So now everything's the same. Back and forth and back and forth. That should get it. I think that got it. I think that got it. We'll see. Yeah, I think they got it. So cool. I keep, yeah, it's annoying. I can't drive these things very good. But three is off, and then boom, and off, and then boom, off, and boom, and off, and boom, and off. Let's see what that does. It's supposed to be fast. I mean, I had it working a minute ago, but it's you gotta kind of hit it right. There we go. There we go. There we go. You see how all the forces are kind of just, they don't really have a choice now. They're all there. That's the Lewis drift, I think. You gotta give it some time. Yeah, yeah, yeah. There we go. Okay. See? And it's not easy to do. So I'm not sitting here saying this is simple and physicists are stupid because they didn't figure this out. You're not figuring this out. This is counterintuitive. You're not supposed to be able to do this. All right, every equation we have just says this is completely impossible. But it's not because of this stupid chain. Um, and I explain in my, you know, let's see, what do I explain? I explain it here in this, how this works. I mean, I know it doesn't make any sense, and it doesn't, and you can see it's not easy. It doesn't just fly out of its position in space. You have to kind of do it. And so let me try to do it one more time real fast. So you just kind of lash that thing around, right? And then you got to kind of get it to kind of fold together as best you can. I mean, it's just terrible. Oh, but you see, I'm already moving. It's gone. There's no way you're putting it back in where it was at, right? So this is the Lewis drift. It's not magic. It's not uh, it's not breaking the laws of physics. It's literally working within the laws of physics, but it's trying to uh, stay on its center of mass. It's staying in its center of mass. It's doing exactly what it's supposed to be doing. It's just the forces because there's friction in this. Every time this chain jerks together, instead of getting a torque like you get a torque, this is offering a torque. So we're getting a torque here. But the torque isn't translated as a torque because it's a chain. You got these links, right? So let's stop this and you look. You see you got these links. And so yes, while it's out like this, you're getting a direct translation of force. But the second I turn it and I start rearranging how those things are clacking together, well, you're just not getting the same force. I mean, you are. It is equal and opposite. I'm not saying that it's not. It's just it's asymmetrical. So yes, eventually you're going to get the equal and opposite reaction, but this is time invariant. So um, you got symmetries that the conservation of energy is in momentum um, uh, you know happen from. So this leads to the conservation of energy. The spinning leads to the conservation of momentum. But what this is doing is taking a time. So you're supposed to be able. You have to conserve time as well too in this equation, and that's what this is doing. So this is taking advantage of time in the equation. So look at the math. You can see how this does. You can figure this out, and you can see it just doesn't pop out of position super easy. Like you have to nudge it. You have to get the right directions, and just accidentally doing it doesn't really work. I mean, it does because that's kind of what I've been doing. It's just, poking it, making it go because I don't, again, not really sure exactly where this translates, how it translates, but I do know it does. So thank you so much.